You ready to write those out?
Yes, sir.
You ever quit talking?
Don't ever speak to me
Well,
like
whenever
that.
you quit talking.
You ain't talking about power.
You okay this morning, buddy? How you doing?
Does that say power of power?
Yep.
Okay. Power of
Do we need to leave a space? Or are these just formulas?
These are just the rules.
power of solid.
Huh?
Zero.
I'm a desk.
Yeah, but
Alright, these are the power rules that we're going to start off with today. I'll scroll up so you can see the last ones at the bottom in a second. We got the product of powers, power of power, power of a product, negative exponent, zero exponent, quotient of powers, and then the last one that you can't see is power of a quotient.
this is mountain. Like, those would be the issues on mountain, but it's getting plus one.
We gotta memorize these.
Can if you want to.
I think you go on this weekend and I forgot how to write.
Just for
Yeah, I know.
I'm getting something on this weekend. Closing. That's the only thing.
Why is it M and N?
That's just
examples, bro.
examples.
Let's,
Go scroll it
bro,
down.
you'll get good though.
Hey, Connor, go scroll it down.
Because
Everybody got to at least quotient? Where are we?
No,
I'm not power of
Oh,
product.
yeah,
Power of a product?
I'll,
He's slow. Give him a second.
I'm slow. What is that?
That's the last one.
I don't remember anything from the other one. How do you remember that? Like, that was last year.
Last year.
Eighth graders have the option to take addition for credit.
That shouldn't be fair. You
Yeah, I
shouldn't
know.
be able to get a
When
grade
did
for your 4 years.
I got a credit. I took a credit for it, but is that art and?
Yeah, but that's not fair.
Because I didn't get the option. I could be graduated.
Yeah, same. Not I wrote on my classes, but still.
Yeah, but like if one of my papers like, but you can have a lot of sense. Switch to art. Yeah. When was an art wrong? I was like, oh, that's happening.
Dude, you have to take a look at the summer class.
So,
Land.
Or just,
Way too much.
It's fine.
or,
I'm taking college. Or just do.
Oh, quit.
But I can't
Is that just
why? You're not teaching out here, you're crazy.
I want to get
Dude, you're gonna be a physical Dude, why is it so retake? No, don't do that. Don't take that. Okay, you can do that job, just don't take that class.
If you don't take it now, you're gonna have to take it. You're gonna have to take it again.
so bad?
Yes, I'll take it. I want to take that. Grace and Katie Brian took that, and it's one of the best things that it's one of the people.
Yeah, they really are.
Your finger. And then just
Oh,
follow
yeah,
it.
they
You're not-
Yeah, for real. I guess if you're a twin, you're smart. Like, all the twins are smart. Every single one we have. I mean, Sean is there.
Go down.
4 sets of girls that we have.
They're
Them
also-
two, and then Jasmine.
Everybody got them all? Okay.
That's racist.
I mean, we sent that to.
There's not any new ones up there. You learned these in Algebra 1, but you gotta review them.
Algebra 1, that was years ago.
Me and Dylan.
That was probably my favorite math class. She was so cool.
I thought I was.
She was kind of like Miss Taylor. No, she was I miss
Actually, it might be the office. I mean, that's what I meant. It might be the office. Look, I said,
We got this one all. Except for like,
my mom's driving.
That is like,
Yeah.
all right,
I mean, he didn't see, but really.
Power.
And I was like, no. What is it?
Nothing.
I was about to say, Stephen.
Come on, buddy. Come on, girl.
Yeah, I think you
Then you went back in with it, bro?
Okay, so what we got here, y'all, we're gonna go through several of them, and then we got a couple more rules that we gotta learn when we got radicals.
Oh,
This
these are
one's-
easy.
Yep, this one says 7 to the 1/4 times 7 to the 1/2. Now, we're gonna simplify these as far as we can to still have whole numbers. If at some point it turns out irrational because it doesn't have a perfect root or a perfect power or whatever, then we'll leave it. So, same base, just like on the rules that we just copied down, 7 and 7's the same, just like the A and the A was.
It'd be
This is
7
multiply.
3/4.
So what did the rules say to do, Landon, when we had same
Add
base
the,
and multiply? Very
exponent.
good. So we're going to have that same base, and we got to figure out what 1/2 plus 1/4 is. Which, Landon is correct, is 3/4. Okay, now here's what I was talking about to know if that's where we stop or not. If this can break down farther and so that our answer is still a whole number, we're going to keep going. If not, we're going to stop there. So remembering from Friday, this is power over root. So I've got the 4th root of 7 cubed. Well, I know 4th root of 7 is not a whole number. That's no good. What about 7 cubed? Would that be a 4th root? Try it in your calculator. See what you get for 7 to the 3/4 power. Does it come out a whole number or not?
Nope.
You already tried, Speedy?
Yep. No, I just guessed. I don't even know how to do this anymore. I think I lost it.
I always see.
How do you do it? Oh, math?
So you can't just stop that in the calculator, right? Gave me a decimal.
Idiot.
Say that again, Dawn. So we're stopping there.
4.30.
So 7 to the 3/4 power would be our final answer.
Speedy.
Okay?
Oh, back up.
Yeah.
Wait, what? Where's that 4.3?
7 to the 3/4 power is our final answer, because when we get a decimal, we're leaving it as a...
Wait, so you did the 4 out of the house,
Not
the
that
7,
hard.
you did that, and if it equals decimal, that's your answer.
Right.
Because
Because remember, this is power over root. I was just checking it to see.
Okay.
That was a mistake.
So where you get the 7 to the 3/4 at? You just
Added my powers.
That was your shoulder.
Power rule.
Racetrack's undefeated.
Move 4 to the 6. Oh, these bats are not undefeated.
Oh, we definitely are.
Basketball game?
Alright, we got 6 to the 1/2 times 4 to the 1/3 to the second power.
You multiply.
Okay, so Stephen and Landon are on the right road. This is power to a power. Anytime we've got a power outside of parentheses, we have to distribute that to the powers that are on the inside. And we do that, what's the rule that you copied down about power to a power? What do you do with them?
Multiply.
Multiply them is correct. So here I got 1/2 times 2, which just makes that just 6 to the, y'all be quiet, 6 to the first power. 1/2 times 2 is just 1. Okay, so times 4 to the 2/3 power. Okay, now what do we got? Do I have a product rule here? No, I don't. Stephen's right, because the base is not the same. This is a 6 and this is a 4. That's not the same, so I can't just add my powers. So this is my answer.
That's the answer.
Wait, so you wouldn't multiply it?
Nope, because that 2/3 is on the 4, so that would be multiplied by something different.
What?
You get a whole number.
On the what part?
When you multiply?
6 times 4, is that what you're talking about?
No, 6 times 4 and 2/3.
Make sure you put the 2/3 just on the 4.
Let's see how you got that.
I got 15.11.
You get
28.
You don't have that as a power.
Oh.
You big dummy.
I can't go to that thing for volleyball. I got scheduled at work.
Quit hitting
Got
me
over a
if I
week to
hit
get
you.
off. Whatever.
They have to let you off. It's a school function.
No.
No, I didn't tell her because I forgot about it.
I didn't even know about this the other day.
You didn't come, yeah, she told us. She told us on told us.
She wasn't there. I wasn't there.
Oh, yeah.
That's
Weren't
right.
you?
I'm the one.
Have one.
Alright, we got 4 to the 5th times 3 to the 5th, all to the negative 1/5
Oh
power.
my goodness. I need an eraser.
Yeah.
Look.
Couple of different ways we could do this. It is power to a power, that is true. Easiest thing to do, you need to see that both of the powers in that parentheses are a 5. Right? So that would be the same as if this said 4 times 3 to the 5th right there. Because you would distribute that 5 there, right?
Yep.
And then you still have the negative 1/5 out there. Okay, now the reason that was good, and we couldn't do that on the last one because they weren't the same power. They were this time. That made a different problem. The reason why that's good there now is because you know what 4 times 3 is. So we have 12. Now what do we do with these powers? Multiply them. That is a negative 1. 5 times negative 1/5. Now we're down to the negative exponent rule. No, we don't have an I. What do you do on the what the negative exponent rule say?
You put it over 1.
Good, goes on bottom and becomes positive.
Yeah, I knew that.
Yeah, you did.
Dude, you don't even know.
I'm gonna shoot this out.
It's kind of icky.
Started off, yeah, had negative exponent, had power to power in it.
Also, I didn't do it last year.
No.
I didn't know you didn't know. I thought about it till just now, so. I mean, I was still before it's not when I saw that.
Alright, we haven't done any division ones yet. Let's look at a couple of those.
Division. I hate division. Yeah.
Alright, got a simple one to start with. 5 divided by 5 to the 1/3. It's same base, 5 and 5. So what does the quotient rule say to do when we have same base? What happens to our exponents?
They're just subtracting.
Subtract them,
Yeah,
right?
subtract.
So I'm going to have 5. What's the power on this 5?
0.
Nope.
1.
1.
There.
And then 1 minus 1/3 is 2/3.
What?
1
Oh,
It's
minus.
a whole number.
Yeah.
dude, nobody.
Will that go farther and stay a whole number?
Let's look. Give me my calculator.
Have your calculator.
Definitely.
You ought to be able to check that one in your head. 5's are
Nope,
easy to work
it
with.
will not.
Good, because power over root, that's 25, 5 squared, and that's
Yep.
not a perfect cube. So that's it.
You did not tell me anything.
I told you it was going to be 5.
My first is the first two were now so much more.
That was quotient rule. Quotient of powers. Quotient of powers.
I figured.
No.
I'm like marking them down.
Yeah, that's good. So you know where an example is.
Oh crap! I should do that.
So I have a mark 1, 2, for professor, and I'm just going and putting a number.
Yeah, I'm gonna do that.
So like 1, 2, 4, 6.
What's one?
Product and diagram.
It just goes down.
Yeah, I just put it.
Was it click down there?
Wait, but
1 through 7.
number, but it's not. But
In
it's
order.
number. What?
It's not in order, but how she's making it here.
Yeah, that's what I was
It's
thinking.
1, 2, 4, and 6 is what we have so far.
Alright, I got 42 to the 1/3 divided by 6 to the 1/3 all to the second. Remember we did a multiplication one a minute ago where it was the same power throughout. We have that here. Inside that division problem, they both have a 1/3 power, right?
You would just divide them.
We are, you're right. The first thing I need before I divide them,
Simplify that.
I took that 1/3 off of them. Because it's the same, right? It's working backwards there. Now I'm ready for what Landon said. I want to divide. What's 42 divided by 6?
It's 7.
And what do you do with these powers here?
You just add them on. Multiply them.
Multiply them. Will that simplify any?
No.
Right, that's it.
Keep saying that. But it's dead. But yeah, no. Don't change it yet.
Okay.
What?
So do we like dress up for this thing, you know?
No, we're jeans in your volleyball shirt.
Wow. So the 2 over here.
Yeah, 7 to the 2/3.
Okay, she's
Alright, gonna look at some radicals now. Alright, we got the cube root of 135. Directions say to write that in simplest form. First off, is that a perfect cube? Does it come out as a whole number if you do the cube root of 135 on your calculator?
No.
No. So what we have to do then is find the biggest perfect cube that will go evenly into 135. Okay,
Okay, I'll
perfect
figure that
cubes.
out.
I know 1 cube's 1, 2 cubes 8,
Is it
3
45?
cubes 27. What'd you say?
No, it's not.
4 cubes 64. 5 cube is 125. Okay, so if I go bigger than 125, I'm going to pass it.
Yeah. I think it's 27.
Will 27 go evenly? Do 135 divided by 27.
Yeah.
How many times?
5 times.
So this is the same as the cube root of 27 times 5. Now we've done this before with square roots. It's the same thing. What's a perfect cube in this case gets to come out and play wiffle ball. What's not has to stay in the house. Remember that? What's the cube root of 27? 3. So we bring the 3 out. 5 has to stay in. That's it.
I still don't get it. We've done it about 200 times.
Why did I bring a 3 out?
Because the 3's on top.
No. Because that's what the cube root of 27 was.
3 times 3.
I can still get crap. I'll throw it a bit out here.
So we're off of those rules now. Radicals have different stuff. Alright, this one is one that people sometimes have a harder time with. It says the 5th root of 7 over the 5th root of 8. Now, as it is like that, 5th root of 7 can't be broken down, and the 5th root of 8 can't be broken down. They don't have a perfect 7th or a perfect 5th in them. If I made a list of perfect 5s, there's not anything I can bring them out. And the smallest perfect 5 other than 1, 2 is 32. 2 times 2 is 4 times 2 is 8 times 2, 16 times 2 is 32. 32 is bigger than both of those. So I can't bring a perfect 5th out like we did on the previous problem. The rule with radicals, why I don't know, whoever made up the math rules came up with it, is that you can't leave a radical on bottom. Y'all ran into that a lot in Algebra 1. Can't leave a radical on bottom. So what we got to try to do on this is get rid of that 5th root on the bottom. So I'm looking to see what will 8 go into that is a perfect 5th root. And I just told it to you. 2 to the 5th is 32. 8 times what is 32?
4.
4. So I can multiply
Why 4?
by the 5th root of 4. Whatever I do on bottom,
Yeah, to do on
I
top.
have to do on top.
Yeah, you tell it all.
Okay, so on the top, what's the 5th root of 7 times the 5th root of 4?
That'd be
Yeah, be the 5th root of 28. You just multiply, when your root's the same, you just multiply what's underneath. Okay, so here, be the 5th root of 32. Now, we know what the 5th root of 32 is. That was the whole point in that. 5th root of 32 is 2. Can I break that down any?
No.
No. No. We know the smallest perfect 5th is 32, and that won't go evenly into 28, so that'd be it.
I'll give you different numbers. We'll see if you can figure it out. I did.
Now, that radical that was on bottom was just one term. Started off as just a monomial there. Okay, when it gets a little bit different is if it's a binomial. We got to multiply by the conjugate. So let's look at one of those.
Someone ate a Reese's.
Let me go back. I already forgot.
I was like, why are you eating it? Okay, it's not big enough for your Reese's.
I was just like,
But I think it is. Probably.
Quit
Okay,
hitting
so
me.
we got 1 over 5 plus the square root of 3. 5 plus the square root of 3, nothing about that can be broken down. 5's a prime number, square root of 3 doesn't have a perfect square in it, nothing we can break down there. Okay, but we just talked about can't leave a radical on bottom. Now this radical that's on bottom is part of a binomial. When we cancel out a binomial, and we did this on our last test that we had a week or so ago, we multiplied it by the conjugate. That means the 5 stays the same, the square root of 3 stays the same, we just change the sign. If it was plus, you make it minus. If it was minus, you make it plus. So this one, we're going to multiply both parts, top and bottom, by 5 minus the square root of 3.
I need the following students to the office: Leighton Withers, Hayden Gibson, Tori Allen, Gracie Nash, and Elizabeth Pilgrim.
So good news on the top, you're just multiplying 1 by that. So that doesn't change anything. 1 times 5 is 5. 1 times the negative square root of 3 is the negative square root of 3. Now on the bottom, remember the whole point in that is to make the radicals cancel out. So when we start foiling, it's going to get me 25. This is going to be minus 5 square roots of 3. And this is going to be plus 5 square roots of 3. That cancels. Then I got minus the square root of 9, which is 3. Simplify that on the bottom. 25 minus 3.
Yep, that's right. I don't know what you just did, but.
Is this what our next test is going to be?
I didn't go there.
Some of this will be on there, yeah.
Yeah, these two, they don't.
Alright, there's some easy stuff that goes along with this, so let me find you some of that so you can get some confidence back real quick. Okay, first one that I got there, that says the 4th root of 10 plus 7 4th roots of 10. 4th root of 10 plus 7 4th roots of 10. That's just like terms. When your radical and your root are exactly the same, then it says add, you can add. So I could say this is like, remember this is an understood 1 out in front of this radical, right? So I got 1 of those things plus 7 of those things, which would mean I have 8 of those things.
That's the answer. That was easy. Those super duper levels.
Imaginary one, so like how I do an X.
Alright, can I do that on this one?
No, you cannot.
Not yet, you're correct, because 54 and 2 aren't the same thing. But 54 have a perfect cube that goes into it.
8, 7, 6. One of those 3.
Perfect cubes. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. That was too big. So I'm looking at 27 and 8. Will one of those go evenly into 54?
8.
No.
87.
No, 8 times 7.
That's
I thought you
26.
said
27 does?
27 does how many times?
2.
So this is the same as the cube root of 27 times 2. Shh, we're breaking that one down. And what's the cube root of 27, Landon? What's the cube root of 27? 3. So the 3 gets to come out and play. And the 2 stays in. Now drop down that other one that we've had. Now it's just like the first problem. I have 3 of these, and I'm subtracting 1 of those. What do I got?
You have 2.
2 of them.
Yeah.
Good job, Dalton.
I don't know how to say
Get a
that.
Nobel Peace Prize.
Good.
You're being a good.
That'd be
I mean, I get 2 more.
You have a bug bite on your neck.
Dude, I need contacts.
Sitting on my third rib my neck.
She said, yeah, it's gonna
Yeah, that's where you
deal with
live.
bigger neck. Anyways, 3 weeks.
Rarely hitting you, bro. This whole man.
I've never had one on it.
Right
Alright, we got the cube root of 64 y to the 6th. Directions just say to simplify. So I don't have anything adding and subtracting. Don't have to worry about that. There's no fraction stuff. Don't have to worry about that. I'm just looking for what I can break down. I want to bring out as many perfect cubes as I can. Okay, we've made a short perfect cube list 3 times now. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. Whoa, that's good news. Because that means this 64 is a perfect cube. Okay? So that means I can bring 4 out to play. And I'm done with that. Now, what about y to the 6th?
No, I ain't combo.
Isn't that the same as y to the 6th?
Yes.
Y cubed times y cubed makes y to the 6th, doesn't it?
Wait a minute.
Because power rule, 3 plus 3 is 6.
That's
Why do you have the 4 out there?
I do.
What is that little
I'm
thing?
just working
to
on
the
just
left?
the 6.
Oh,
I don't know.
So it's gonna be 4 with the 3
Is that
and
it?
6.
Now, on this, what's the cube root of y cubed?
It's contact. That's full.
What's the cube root of y cubed?
27.
Y. How many of those do I have in there?
2.
Now, shorter way to do that. Anybody know it?
Top of the calculator.
6 divided by 3. If it'll go in evenly, you can do that. If not, you got to break it down like I did.
Give me one.
Paper?
No, straight peanut butter.
There's peanut butter in there?
Yeah.
I knew I tasted something.
You relation?
No, okay.
What did it say? I'm a cannibal.
You should do a bunch of peanut butter.
Didn't? Yeah. That's why I eat peanut butter and crackers like every day.
Come back to call.
He's gonna eat it. Told you. Don't
Alright, we got the 4th root of x to the 4th over y to the 8th. When that whole fraction is underneath the 4th root, you got to remember that means you're 4th rooting the numerator
Operator.
and the denominator. Okay, what's the, on the numerator, shh, on the numerator, what's the 4th root of x to the 4th? Good. The 4th root and the 4 cancel out. When it's the same power and the same root, remember power over root 4 over 4 is 1. So it cancels out. 4th root of y to the 8th. That's y squared, right? I just showed you that trick. You can divide them and see if it'll go evenly. 8 divided by 4. That's it.
And that one looked like it was going to be harder.
Nah.
But it wasn't.
Didn't I? Bro, tickled me.
Tickled?
Yeah, he tickled me.
My fault, bro.
You get me.
Now, let's do one where it doesn't go evenly now.
Well, we have every class together. All 4 trips too.
You can microwave uncrusted.
I warm them up all the time.
God bless your soul.
Or you wrap it in. I wrap it.
I don't warm it for like 5 minutes.
Alright, we got the 5th root of 4a to the 8th, b to the 14th, c to the 5th. The directions just say to simplify. Alright, so perfect 5th. First off, shh. There's nothing adding, subtracting, no fractions. Don't gotta worry about any of that nonsense. Will 4 break down?
Yes. No.
Is there a perfect 5th that will go evenly into 4?
No.
No, we already said the smallest one other than 1 is 32, and 32 won't go into 4. So I know that I'm going to have a 5th root of 4 in my answer. So I'm going to write that over here to save it. I know that's going to be in my answer, okay? Now I'm moving on to the A. I'm going to go one variable at a time. I'm moving on to the A. So let's look at just the A. What is the 5th root of A to the 8th? This one doesn't divide evenly. I can't do that trick. I can't say 8 divided by 5. So what I'm going to have to do is break A to the 8th down into fifths. Okay? If I had a to the fifth, what other a power do I need to make an 8? 5 plus what would make 8?
3.
Okay, now here was my purpose in doing that. This one, 5th root of a to the 5th, an a gets to come out. And then that one has to stay in. Okay, so for my a's, I'm going to have an a, and then I'm going to have a 5th root of a cubed. Okay, I'm going to have, on these answers I'm saving over here, I'm going to have a lot to put together in the end. Okay, now let's go to our b's. We've got the 5th root of b to the 14th. 14 divided by 5, that's not even. So I want to break that down into perfect 5s. 5, 10.
15,
I need 14, so what does my next one need to be?
14.
I've already got 10. 4, good. Now, 5 and a 5th power and a 5th root cancel out, so this b will get to come out. This b will get to come out. That means b squared is out. And b to the 4th is in.
Con, so nifty.
Okay, so far this black, red, and blue over here is what I'm going to have to combine for my answer. I've got one left to do, and it's the easy one. 5th root of c to the 5th. That's a perfect root there, so that's just c. Alright, so on the outside, look at the stuff that we've got over here in our answer we're saving on the outside. Got an a b squared, and a c. Okay, so I'm going to write a b squared c. Then all these have a 5th root. I've got a 4 a cubed. Let me erase that c that's in my way.
Stupid.
And then a b to the 4th. That's your answer.
That's 8.
Confusion.
Yeah, this is the last of it. We're going to keep working on it.
I know you'll get you good yarn.
No.
I should really care about my grades. Study work for biology. I thought it was pickle at first. When I first looked in, I really did think it was pickle.
Alright, we will still talk about that stuff and pick up on that as we go. We're also going to add graphing to it, so probably going to graph some of these tomorrow. Okay? The end for today.